a groundbreaking discovery has recently caught the attention of both scientists and space enthusiasts. Bill, a renowned science communicator, made headlines when he revealed that Voyager 1 had detected 300 large objects in space. This revelation has sparked widespread intrigue and raised many important questions about the nature and origin of these objects. What are they, and where did they come from? Join us as we dive deeper into the mysteries hinted at by Voyager's initial findings. For nearly half a century, the Voyager missions have delivered some of the most extraordinary and early glimpses of the wandering bodies in our solar system. Surprisingly, these missions were not designed to endure for this long. Back in the 1970s, Michael Minovich proposed an innovative idea. Spacecraft could harness a planet's velocity to propel themselves deeper into space. Initially expected to last only 5 years, the Voyager missions have far exceeded these expectations. Launched just weeks apart during the summer of 1977, Voyager 1 and Voyager 2 were originally tasked with exploring Jupiter and Saturn. They completed this mission by providing comprehensive data about these gas giants. However, the journey didn't end there. In 1986, Voyager 2 made history by being the first spacecraft to provide close-up images of Uranus, and 3 years later, in 1989, it did the same for Neptune. This monumental flyby of 4 planets earned the mission the title of the Voyager Grand Tour. Rather than concluding their journey, the spacecraft set their sights on a more ambitious objective, exploring deep space. Now, 45 years after their launch, both Voyager 1 and Voyager 2 continue their travels, sending invaluable scientific data from the farthest reaches of the universe. In 2013, NASA made an exciting announcement. Voyager 1 had officially entered interstellar space, the region between stars beyond the Sun's magnetic fields and influence. It was like stepping out of the busy solar system and into a tranquil, star-filled wilderness. This journey continued in 2018 when Voyager 2 crossed this vast expanse, situated 17.7 billion kilometers from the Sun. Remarkably, Voyager 1 and Voyager 2 remain the only spacecraft to have ventured into interstellar space, providing us with crucial information on how the interstellar medium interacts with the solar wind from our Sun. These pioneering missions have served as our primary source of knowledge about the heliosphere, a protective bubble that shields our solar system from cosmic hazards. The heliosphere, shaped and influenced by solar wind, a constant flow of charged particles from the Sun, acts as a protective barrier for our solar system. Both Voyager spacecraft have served as our cosmic messengers, sending back valuable data about this celestial shield. All this information converges at the heliopause, the outermost boundary of our solar system, marking the transition from the solar wind to the vast reaches of interstellar space. Thanks to the Voyager spacecraft, we've gained new insights into the properties of interstellar space. One significant discovery is the nature of cosmic rays, mysterious, high-energy particles that are far more intense beyond the heliopause than within the safety of the heliosphere. It's like comparing the calm of a quiet garden to the hustle and bustle of a crowded street. But this cosmic tale doesn't end there. NASA expanded its understanding by integrating data from newer missions with Voyager's observations, piecing together a more complete picture of how the Sun interacts with the surrounding interstellar medium. In an unexpected twist, in 2023, Voyager 1 picked up a faint, low-frequency humming sound, corresponding to vibrations in the small amounts of gas drifting through interstellar space. Nicole Fox, head of NASA's Heliophysics Division, emphasized the significance of these findings. Over the past 46 years, the Voyager missions have provided invaluable insights that have transformed our understanding of the Sun in ways no other spacecraft has achieved. This incredible space journey is even more impressive when considering the Voyager spacecraft's power limitations. Both spacecraft rely on plutonium-powered systems, but as the plutonium decays, it generates less heat, gradually depleting the spacecraft's energy. To tackle this challenge, NASA has been forced to make difficult decisions, shutting down non-essential systems, including the heaters that help keep the instruments warm in the freezing void of space. Yet, despite these challenges, all 5 key instruments on the spacecraft have continued functioning since 2019, defying expectations. NASA scientists remain baffled at how the Voyagers continue to operate in such cold conditions, where other spacecraft would have frozen. This ongoing mystery adds another layer of awe to the legacy of these remarkable explorers, whose journeys continue to surprise astronomers and deepen our understanding of the farthest regions of our solar system. The heliopause, the boundary between the Sun's influence and interstellar space, is not a static phenomenon. Instead, it shifts and forms unusual angles, leaving scientists both intrigued and perplexed. The idea that the heliopause could change shape isn't new. In the last decade, data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer satellite, IBEX, has shown evidence of its shifting position. These spacecraft provide crucial measurements of the cosmic boundaries, even though they only capture snapshots of specific locations at particular times. D. Eric J. Saran, a space physicist from Princeton University, shared his excitement in an email to Vice, noting that the IBEX satellite has been supplying valuable data that is helping scientists refine their predictions about the heliopause's future movements. What makes the situation even more intriguing are recent studies that have challenged long-standing assumptions. In 2014, the IBEX satellite detected an unusual brightening of energetic particles, hinting at irregularities in the heliopause. These anomalies didn't align with current models, much like an unexpected plot twist in a story. Researchers also observed a significant shift in the position of the heliopause over a short period, which might explain why Voyager 1 entered interstellar space in 2012, followed by Voyager 2 in 2018, despite the 6-year gap. These surprising findings challenge previous understandings of the heliopause, sparking debates among scientists. The search for answers is ongoing. NASA's upcoming Interstellar Mapping and Acceleration Probe, IMAP, set to launch in 2025, promises to uncover more secrets about the outer reaches of our solar system. Meanwhile, the mysteries persist. In May 2023, Voyager 1 encountered an unusual event. The spacecraft's Altitude Articulation and Control System, AACS, responsible for managing the direction of its high-gain antenna, began sending back confusing data. Instead of the usual health reports and scientific observations, it appeared as if Voyager 1 was struggling to communicate. Fortunately, NASA quickly identified the problem. The AACS had been relying on a computer that had been inactive for a long time. The solution was simple. They sent a command to switch to a functioning computer to ensure data transmission continued. However, the cause of the AACS's strange behavior remains unclear. Nearly 50 years have passed since Voyager 1 and Voyager 2 began their historic journeys, crossing unimaginable distances and exploring the unknown. Despite their 1970s era, across such vast distances, ensuring these spacecraft continue their work. Keeping Voyager running is like providing cosmic tech support in the darkest reaches of space, billions of miles from Earth. These legendary spacecraft continue to cross significant milestones, offering profound insights into the mysteries of our solar system. Let's pause for a moment to honor these trailblazing pioneers. The twin Voyagers are now drifting forever among the stars, each the size of a small car, representing the technological spirit of the 1970s. Nearly 5 decades later, Voyager 1 and Voyager 2 continue to stand as humanity's farthest emissaries, unlocking the secrets of interstellar space. Their legacy will endure for generations, reminding us of the boundless curiosity and perseverance that drive us to explore the unknown. The Voyager Legacy, a journey beyond time. As Voyager 1 and Voyager 2 drift deeper into interstellar space, their signals grow fainter, yet their journey continues to defy expectations. Scientists at NASA's Jet Propulsion Laboratory, JPL, remain in awe of these aging explorers, which have become time capsules of 20th-century engineering, still functioning despite the relentless passage of time. A new challenge on the horizon. In late 2025, an unexpected signal from Voyager 1 puzzled mission scientists. The data stream contained anomalies, patterns that did not match any known cosmic phenomena previously recorded. At first, NASA suspected another malfunction, similar to the AACS issue in 2023. However, as engineers analyzed the data, they realized something extraordinary. The signal was rhythmic, almost like a repeating pulse, with subtle variations. What made it even more baffling was its source. The signal was not originating from the spacecraft itself, but rather from somewhere beyond its trajectory, an unknown point in interstellar space. Had Voyager stumbled upon something entirely new? A mysterious interstellar echo. The team at JPL scrambled to decode the anomaly. Scientists cross-referenced the signal with known astrophysical phenomena, pulsars, quasars, and cosmic background radiation, but none matched the rhythmic pattern detected by Voyager 1. Some speculated that the spacecraft had encountered a new type of interstellar plasma turbulence, while others suggested that the signal could be an echo of cosmic radiation interacting with the heliopause in an unforeseen way. Then, in early 2026, Voyager 2, positioned billions of miles away from Voyager 1, detected a similar signal. Although slightly different in frequency, the two signals seemed to be related. This revelation changed everything. If two spacecraft in vastly different locations were picking up variations of the same signal, it suggested the presence of a structured, repeating phenomenon in interstellar space, one never observed before. The search for answers. Excitement spread throughout the scientific community. Telescopes around the world, including the James Webb Space Telescope and NASA's Interstellar Mapping and Acceleration Probe, IMAP, were tasked with monitoring the region where Voyager 1's signal had originated. Meanwhile, NASA engineers devised a daring experiment. They would attempt to adjust Voyager 1's trajectory slightly, reorienting one of its remaining instruments to gather more precise data. Given the spacecraft's dwindling power, any change in operations came with risk. Yet, against all odds, the command was successfully transmitted across 15 billion miles, and Voyager 1 slowly adjusted its angle, focusing on the source of the mysterious signal. What it detected next would send shockwaves through the scientific community. An unexpected discovery. As Voyager 1 continued its observations, the data revealed something astonishing. Fluctuations in the signal coincided with bursts of high-energy cosmic rays, as if something beyond the heliopause was actively disturbing the interstellar medium. It was unlike anything recorded before. Some speculated that the Voyagers had stumbled upon an unknown cosmic structure, perhaps a vast, magnetic anomaly or even the remnants of an ancient stellar event. Others, more boldly, wondered if the rhythmic nature of the signal suggested an artificial origin. Though the likelihood of an extraterrestrial source was slim, scientists knew one thing for certain: the Voyagers had once again rewritten our understanding of the universe. The final chapter. By 2030, Voyager 1 and Voyager 2 will have likely exhausted their remaining power, their instruments slowly shutting down one by one. Yet, their final discoveries may redefine our perception of interstellar space for generations to come. Even when their signals fade into silence, their legacy will endure, a testament to humanity's unyielding desire to explore the unknown. As they drift endlessly through the cosmic void, these twin pioneers remain our farthest messengers, carrying with them the golden records, a whisper from Earth, waiting for another traveler in the vast expanse of space to one day find them. And so, the journey continues. The awakening. As Voyager 1 drifted silently beyond the reach of Earth signals, the world remained captivated by the final transmission. The cryptic, mathematical pulses it had received were unlike anything previously detected in space. While some dismissed it as a natural cosmic anomaly, others believed it could be the first evidence of an unknown intelligence. For years, scientists tirelessly analyzed the data, cross-referencing it with every known astrophysical phenomenon. The rhythmic patterns, the Fibonacci sequence, and the final anomalous frequency shift, none of it fit within existing models of cosmic radiation or interstellar plasma interactions. Then, in 2032, a breakthrough came. A team of researchers at the European Space Agency, ESA, using deep learning AI models designed to decipher complex signals, detected a hidden layer within the final transmission. It wasn't just a mathematical sequence. It was an encoded pattern, one eerily similar to a form of digital compression used in early computer technology. It wasn't just noise. It was information. The hidden message. Working with NASA and international partners, the team reconstructed what appeared to be a simple visual pattern embedded within the signal. When decoded, it revealed something shocking: a series of geometric shapes that resembled an interstellar map. The map, though incomplete, appeared to reference a location far beyond the current position of Voyager 1. But that wasn't the most startling revelation. At the center of the map was a symbol, one nearly identical to the pulsar navigation diagram on Voyager's golden record, the message humanity had sent into space decades earlier. Someone, or something, had recognized it. The signal returns. For 3 years, the scientific community debated the implications of the discovery. Was this a naturally occurring cosmic phenomenon mimicking intelligence? Or had an unknown entity deliberately sent a response to humanity's ancient messenger? Then, in 2035, just as the world was losing hope of ever solving the mystery, a powerful radio signal was detected, not from Voyager's location, but from the exact coordinates the encoded map had pointed to. It was stronger than anything humanity had ever received from deep space. This time, there was no doubt. The signal carried structured data, unmistakably artificial in origin. Earth had been noticed, and whoever or whatever had sent the message was waiting for a reply.